Good afternoon, everyone. My name is Martin Westgate. I lead the Science and Decision Support team at the Atlas of Living Australia, and I'd like to welcome you to our quarterly webinar for, what are we in now? July 2023. Before we start, I'd like to acknowledge that I'm presenting this webinar today from Black Mountain campus of CSIRO, which is in Canberra, which is, of course, on Ngunnawal country. I'd like to pay my respects to the elders of the Ngunnawal people, past and present, and I'd like to extend those sentiments to the peoples of the lands that we're all joining from today. And feel free, if you'd like, to pop that in the chat where you're joining from. I'd love to hear about that. Today, we're very privileged to be here from four speakers from 3 different organisations on the topic of safeguarding sensitive species. So I'm really thrilled about this one. A lot of our talks are great, but here at ALA, part of our core mission is about sharing biodiversity data, of course, and that brings many benefits: better science, better protection for native species. But of course, there is some biodiversity information that simply cannot be shared for the protection of the species in question. And we take that very seriously at ALA, but of course, so do the people who generate that data and provide that data to us, of which there are many organisations around Australia with a great deal of experience. And today we're here to hear from 3 of those organisations. So we're very privileged to have Philip Gleeson joining us today from New South Wales Department of Planning and Environment.
This meeting is being recorded.
We've also got Golo Mara and Rachel Swain from BirdLife Australia. Hi guys. And we've got Helen Ensikat from WA Department of Biodiversity, Conservation and Attractions, and they'll be speaking to us in that order. So I don't want to take up any more time than I have to. I'd much rather hear from you guys. So Philip, I believe you're speaking first.
Yes, right. So I'll just share my screen now.
No worries, thank you.
So I'd like to begin today by acknowledging the traditional custodians of the lands on where I'm found, which is the Darug and Gundungurra people, whose traditional lands meet on the main ridgeline of the Blue Mountains. And I'd also like to acknowledge the traditional custodians of people throughout the country who will be online, and pay my respects to their elders past and present. So what I'd like to talk about is sensitive species data policy as seen through the New South Wales lens. And what I wanted to focus on was balancing the threats related to sharing threatened species data. So in New South Wales, the threatened species are listed under the New South Wales Biodiversity Conservation Act. And under the Act, 1,025 species are listed, along with 45 endangered populations and 150 ecological communities. In our threatened species databases, it's recognised that threatened species are subject to a whole range of threats, and they're grouped into a number of categories there. And although you can see most of these threats are probably ultimately human-derived, they vary in terms of direct threats, like direct take or mortality, all the way through to indirect threats, such as climate change and pest animals and weeds, where humans originated those threats, but the threats are largely operating under their own steam now. It's long been recognised that access to information can amplify some of those threats. For example, direct take and mortality, one of the subcategories of that is illegal collecting, particularly for sedentary organisms. So plants like threatened orchids, for example, can be collected if exact information on where the orchids are found is available, but also other animals that have small home ranges. So, for example, broad-headed snake in New South Wales is at very high risk of collection when people know exactly where it is, where they can go and collect those organisms. But direct take's not the only one of those threats that can happen. There are other indirect threats that can be amplified by providing direct information. And so one, for example, disease risks, where the taxon is of high interest, unauthorised visitation can unfortunately introduce disease. So, for example, the Wallamai pine wouldn't be threatened by people coming in and taking the pines themselves, but unauthorised visitation could introduce Phytophthora. And I understand there is Phytophthora at some of the sites, but there's a number of different Phytophthora strains. So unauthorised visitation can introduce new strains, but also move disease around the site. And so those threats are almost as important as direct taking of the species. Strategies to reduce risk from the information disclosure range from the simple. So the simple option is restrict the information supply completely, don't supply any information outside government departments, through to obfuscating location information. And so what obfuscating location information involves is removing descriptions, like text-based descriptions that would allow a user to find the site, and then obfuscate the coordinates to limit the ability of data users to relocate records in the field. So what does that mean to obfuscate coordinates? There's a number of different approaches out there, but two of the most common ones that are used is rounding of the coordinates, or alternatively doing some sort of random displacement of the location of the organism. So in this hypothetical example, say we had a species that was found at Govett Sleeper in the Blue Mountains. If we apply a rounding approach, then so we round the coordinates, say, to the nearest 0.1 degrees, the represented point will move to the center point of a grid cell, which is 0.1 by 0.1 in size. Alternatively, a random displacement approach would just move the point a random distance in a random direction. The advantage of rounding over random displacement, though, becomes immediately obvious if you can imagine the data goes through a number of hands, and so it potentially could have the obfuscation applied multiple times. If you apply a rounding algorithm to data that's already rounded, what will happen is there's no change to the data, and it's still possible for the user of the data to identify that the true record occurs somewhere within that grid cell. Whereas if you apply random displacement, potentially you can imagine over a number of iterations, it can become quite corrupted, and so it becomes then impossible for the user to derive any sort of meaningful information from the obfuscated data. And so for this reason, rounding is preferred for obfuscation. It's deterministic and repeatable, so it gives the same results whoever does it, and it can be repeated multiple times. It can be applied more than once without corrupting the data. And it also allows some users of the data to use the obfuscated data. So, for example, modelers who often use modelled layers of climate or elevation and so on, they can use the obfuscated data provided that their grid cell is the same size or larger than the obfuscation algorithm. New South Wales Bionet Atlas, which I manage, was established within what was then the National Parks and Wildlife Service in New South Wales in 1981. It aggregates data from several sources, but our larger sources are the systematic flora and fauna surveys conducted within and outside the department in New South Wales, data submitted by ecological consultants as part of the scientific licence procedure. So any research in New South Wales that is invasive in any way, involves collecting specimens, trapping animals and so on, requires a scientific licence, and the conditions of that are that we get the data at the end of the study. And it also includes data from other agencies such as Forestry Corporation of New South Wales. Prior to 2011, all threatened species data were provided to external requests with the location coordinates obfuscated because of the perception of the risk that we've discussed about risks associated with allowing easy access to data. But the policy was seen as unfair by our contributors because they were providing us as-held data, and then for their environmental assessments, what they would get from us was, routinely obfuscated. It was also recognised that restricting information can amplify other threats, which operate in contrast to the threats of releasing information. So one of the major threats to species is habitat loss. And a lot of that habitat loss can happen through legal processes such as mining, road development, rural residential development, vegetation clearing, and so on. There's also habitat disturbance, which might not lead to complete habitat destruction, but things such as forestry, roadworks. And then in the category of fire, although wildfire is certainly outside the control of releasing information, the use of hazard reduction burning is often done at the end of a bushfire environmental assessment code. And for that code to operate, it needs to have detailed information on where threatened species are. So in recognition that there needs to be a balance between releasing the right information to planning processes to avoid these sort of risks, New South Wales, over a number of years, came up with a sensitive species policy on how to distribute data. And what was decided on is that species would be divided up into several categories of sensitivity. So the highest category, species of high biological significance, like the Wollemi pine, for which no records would be provided at all. And these were species that were considered to be such a draw that people wanted to visit them, but they also had the advantage that they occurred completely within conservation estates. So there was no reason for distribution of data outside government departments. And then we have two categories where Category 2, species considered to be at serious risk from threats of disturbance or exploitation, and Category 3, where species are considered to be at medium to high risk of those threats. And so what we then have is we have a matrix of what data people will get according to what level of access they have and the sensitivity of the species. So you'll see government users get access to all of the data in complete level. Licensed clients who sign a sensitive species license with the department, they won't get access to the high sensitivity data, so sensitivity class 1. Sensitivity class 2 data is denatured to 0.01 degrees, which is approximately a kilometre. But sensitivity class 3 is provided complete and as held, as are the records of species deemed to be not sensitive. And that's contrasted with the public, for whom all of the sensitivity class levels are provided, either not provided or obfuscated. And when they're obfuscated at a higher level. So what that means is that allows us to categorise some species into sensitivity class 3, where it's considered important that important enough to get the detailed information for planning processes, but the general public doesn't have a valid reason to get detailed locations of those species. And so what does that look like in practice for our website? So this is a view of our Bionet website. So I've just got a can search here, which is a search for all records of plants in the genus Calodenia, which, for those who don't know, is a genus of ground orchids. And what you'll see is that one of the species there is an endangered species, Calodenia arenaria, and it's flagged as being sensitivity class 2 in the output. And there's an annotation indicating that the coordinates will be denatured to 1 decimal place. And so when we map those records, you'll see I've mapped a common species, Calodenia carnenia. And you'll see the records for that in blue. They're distributed throughout and appearing exactly as they appear in the database. Whereas in contrast, the sensitive species, Calodenia arenaria, the records have been denatured to the nearest 0.1 degrees. And that shows in the way that they're distributed on the map. Additionally, if the user clicks on the information record, they'll see the same thing. So the coordinates have been rounded to 1 decimal place, and text in location and location notes has been removed. And so through that process, which has now been in operation for, I guess we're getting on in 12 years, New South Wales has been able to strike a balance between the need to restrict data on some species while pursuing a policy of maximising access to records for planning processes, in recognition that planning and the threats that are associated with it around habitat loss is quite a diffuse process and can happen at multiple levels of government, local government, and involves a lot of players, including our licensed contributors. So I'll leave it there.
Thank you, Philip. That's really it's amazing to see that sort of long history of work that you guys have been doing on there. When you consider that the Atlas of Living Australia, for whom I work, has only been around 12 years, to see people having worked on that for such a long time is really fascinating, and hear that history. We'll hand over to BirdLife now, and just while you guys are setting up your slides, I'll mention for those who are watching from home that you guys should be able to see a tab on the side of your browser that says that there's an opportunity for questions. We are monitoring that. There's time for questions, but we'll mainly have them during a discussion at the end of the presentation. Feel free to start queuing up questions now if you wish. So Rachel, over to you.
Hello, everyone. I think Golo is starting the presentation, so over to Golo.
That's right. I think I'm kicking us off. So thanks for having us. I'd also like to acknowledge the traditional owners of the country we are meeting on. And I'm up here in Cairns in the Yurrugunji country, and Rachel is in Boon Wurrung country. Yeah, so we've interpreted the safeguarding sensitive species quite widely, looking at also the restricted access species data framework that ALA has put in place. And sorry, I think you need to click us on, Rachel. And yeah, so the sort of engagement with that lies in the citizen science team, which I lead, and that has Bird Data, our database, which goes back almost 50 years. Urban birds, key biodiversity areas, seabirds in it, and yeah, I'm actually an active contributor to that as well, as you can see, in terms of standardized surveys and other surveys in key biodiversity areas, etc. So it's great to be using the product that that you're promoting. Not sure everyone's familiar with BirdLife, but next slide, please. Yeah, so BirdLife's been around since 1901. We've Australia's largest bird NGO. We've got 130 staff in all states, loads of supporters and contributors to our work, which we thank profusely. We've got branches dotted all over the country, and we've got an ambitious new 10-year strategy, which is one of the reasons why we're really thinking to get engaged with the data more, use the data better for conservation. So, lots of people might know us as the people that do the Aussie Bird Count, which is, of course, a massive citizen science event, over 100,000 people. But it stands on the shoulders of giants. We've got the first continent-wide atlas in the world in 1984. Is the Bird Atlas, another edition in 2002. So that goes into our database as well. And we use this data for Hands Up, which will soon be online, and publications in Australian field ornithology, etc. Over to you, Rachel.
Awesome, thank you. Hello everyone, I'm Rachel and I'm the Engagement Manager for Citizen Science at BirdLife, and I work with Golo. I'm predominantly working on the bird data platform. I've got a background in engineering and I've studied environmental science and worked in forest hydrology and data analysis. And now I'm at BirdLife, so I chucked a couple of photos of some field work that I got to do last year. So it's a lot of computer work, but yeah, we get to do some fun stuff at BirdLife. Yeah, so I wanted to start by just quickly introducing bird data because not everyone will be familiar with the platform. And I guess a good way of starting is by saying we have 23 million records. It's a massive database, and it's home to most of BirdLife's data. And that data dates back over half a century, which is pretty significant. At the moment, we have about 9,000 active counters, which is pretty amazing, and we're really grateful for their efforts. And yeah, Bird Data is a bespoke survey tool that actually supports local and national programs. So it does a lot of things. And we share the data with government, scientists, consultants, and NGOs. And I'll kind of go into a bit more about who we share our data with a bit later. And it's worth going into a bit of detail about bird data. So it's not just a database. Bird data is really, we think of it as three things. It's a database, it's the interface, and community. So with the database, a lot of work goes into maintaining a huge database like this. So that involves checking the data quality and vetting our records, and we do that with staff and volunteer efforts. And as custodians of this database, we have to make sure that we're sharing the data with as many people as we can that need the data to make sure it's having the impact, whilst ensuring that the data is protected, as we've already touched on. And so the interface is, when I talk about the interface, I mean that's our web and our app platform. So we have a web interface and an application so that you can submit your surveys both ways. And we provide tools and work collaboratively with our volunteers to develop tools that enable them to do structured surveys, which is basically focusing our efforts on areas and species to make sure that the data collected has the most impact. So we're really proud of our programs at BirdLife, and I've highlighted a few in this screenshot here. You can see we have a lot of specific programs that relate to species or areas. So yeah, that's kind of our pride and joy at BirdLife is our programs. And yeah, lastly is community. So probably the very that's the basis of the BirdLife of the bird data database. A lot of our data comes from volunteers, and we need to make sure we're informing our volunteers of where the data is being used. We like to provide webinars and training materials to upskill our volunteers. And we like to listen to our volunteers to make sure that the platform is working for them in the best way. So recently we did a survey, and I think this is a really interesting thing to highlight, that bird data volunteers are really interested in bird conservation. So that's their main motivating strategy. 89% of our volunteers do bird data surveys to contribute to bird conservation, which I think is really significant. Yes. So that's a bit about bird data. That's over to Gola.
So yeah, and I guess this lead up is really setting the stage for why we do feel quite strongly about sensitive species and why we have to have these sensitive species policies. So a couple of the programs that Rachel has pointed out, like the birds on farms, this is all people's private properties. So you've got to keep a lid on that and make sure that they don't have people come in. As Phil pointed out, you don't want to have up here in Cairns, it's the Panama virus. You don't want to have that in your banana farm, that sort of thing, just because someone wants to see a bird for their list. So there's all that sort of thing, which is about building the trust of the community to work with us on conservation and to share the data with us and to get the exact locations as well. So and we work a lot with private property owners or First Nations groups, which are obviously also concerned about that access. But there's always a dark side. There are people in the birding community, luckily not that many anymore, but that are into egg collecting. There's poaching, falcons, parrots, that sort of thing, illegal trade. Our local member up here is very concerned about the parrot trade, for instance. There's the twitching, just getting something for your year list, day list, or whatever. Photography has just gone through the roof, and we were bantering about the beautiful photographs we are able to put into our talks, but some people just get carried away and will be sitting next to a nest for hours, actually endangering the birds. And then there's just vandalism and all those sorts of risks, which the birding community is aware of, the people that are contributing the data are aware of, and if they can't trust us with the data to be safe, then they'll be not sharing the exact locations with us, so that they in fact are doing the randomizations for us, which has all the drawbacks that Phil has pointed out. Next one, thanks. So we had similar sort of setup with the slides. We've got different categories. So some data we don't provide anywhere. You can go on bird data and find out a lot of things, but you won't be able to even type in night parrot. You don't get anything for that. The reason is that it's one of the most sought after birds. It's a CITES 1 listed species, down to a very, very low degree of desensitization for things like the inland western rosella. We're not massively concerned about it, but it's a species that's listed in WA, for instance. So we are desensitizing it very, very roughly. And the screenshot sort of shows you when normally you get a red dot for where a survey was, but for desensitized species you get an orange dot, which means it's not going to be exactly there. So don't bother going there. Next one.
Yeah, and so I just thought I would highlight how we also protect personal data, because that is also an area of concern for many volunteers. And it's worth noting that we don't actually pass on any personal details when we share data. So we talk a lot about sharing data. We don't actually pass on names or details from our volunteers. And actually, you can mark your surveys as private in bird data. So this just means that they're hidden from public view, but it still means they can be provided onwards to our data sharing partners for conservation. So they're still eligible to be shared, but they wouldn't appear in our platform in the Explore view. But you can always view all of your surveys in the My Data tab of bird data. So yeah, as I said, we share with a lot of people, and I think that's, as I mentioned, that's kind of our job as custodians of the database. We share with commercial and industry, government, scientists, large projects such as the Avistep Australia Renewable Energy Platform tool, planning tool, sorry. And this is basically a decision-making tool to help highlight where energy developments, such as wind farms, may have most negative impact on birds. So that's just an example of where our data is helping birds. We share with other NGOs, eBird. We don't share with eBird. We actually receive data from eBird. So we integrate their data into our database where it's eligible. We share with our branches and network partners, Indigenous groups, and of course our BirdLife staff. They use our data for their projects as well. And it's worth noting that for most of these partnerships, we are the data source. So that makes sense because we have a huge database to share. But we do get some data back from these partnerships, as I mentioned, eBird, and from our Indigenous groups and branches. But we'd like to highlight that to help achieve some of the goals in our new conservation strategy, we're going to need to bring in new data sources. So we recognise that other data holders can improve the richness of our data, in particular, where we need to focus on threatened and near threatened species. So I think the restricted access species data framework is really going to help us do that because it's really going to standardise the process. So when we're getting in touch with people to get these data sets, it's going to be so much more straightforward. So we're really excited about that. And if you do have data you think would be useful for BirdLife, then do get in touch. And we've got some contacts at the end of the presentation.
Yeah, and the end is nigh, but I don't want to go to the end without saying before that we are extremely excited about, that someone's taken on this task to create the restricted access species data framework. I think it will mean for the conservation community in Australia that we get more better conservation outcomes. We get more people involved because they know their data gets shared. They know they can trust how their data are dealt with. And they, as a result, probably are more willing to provide more useful, more accurate data. It'll be easier to build the partnerships when everyone knows what the basis is for how we are dealing with each other and with our data. And it will make updates, the sharing back and forth, a lot more easy and fast to make sure that when those decisions are made by New South Wales or WA or by anyone, that they've got the latest data at their fingertips as well, and in a format that they can actually rely on and trust it. So it's building this trust and confidence that we have a nationally consistent network. That probably is a reason why we swallowed it hook, line, and sinker. And then, of course, there's another reason that we do feel strongly about some of the species that are sensitive, and being able to share with a bigger network, saying, well, these are the ones that we are feeling strongly about of keeping sensitive, might inspire others to say, well, yeah, I don't think that's a big issue here, or might say, well, no, now that you mention it, we should probably worry about this species as well and keep our data a little bit more hidden for that species. And this is really something where the whole breadth of people that we have here is important. I discover new issues and worries for sensitive species continuously, especially through the Key Biodiversity Area program. But I thought simple crustaceans, little yuppies, are very popular in the aquarium trade, and never thought that you have to keep them really secret, their locations, but things like that. So it's really great to build up to that standard. And I think this might be our last slide coming up, is it?
Yeah.
Yes. So thanks everyone for listening to us and for yeah, all the questions. There are the details.
Lovely, thank you both. It's a fascinating talk. I've got so many questions, but I'll hold them over the end, and I'm seeing more questions come in during your talk as well. So it's really great for you to share those insights with us. An interesting point about the what we determine to be sensitive and how that can change over time or in different contexts, I think is a really fascinating question. But we'll come back to that. For now, I might hand over to Helen, if that's all right. Are you able to share your screen, Helen?
Yep, just about share. Let me know if this works for you.
Yeah, we'll do.
Okay, how's that?
I can see your screen.
Okay, I will play it. There you go.
Yep, that's perfect. Thanks so much.
Fabulous. Well, thank you very much. So I'm presenting here from Whadjuk Noongar land in Perth, Western Australia. And I'm going to speak about some of our work that we've been doing over the last couple of years. What's quite a new part of the Department of Biodiversity, Conservation and Attractions, which is BIO, our Biodiversity Information Office. So we started as part of a bigger state Commonwealth partnership around environmental regulation and digital transformation. So we've got partner projects in the Commonwealth and also in other agencies here that are around the environmental regulation space. And we a big part of our objective in being set up was to actually establish a new central data sharing platform for biodiversity data from all sectors in WA. So we put out something in as a first release in the middle of the last year and have a really large wave of new development currently underway with a lot of new features. But the basic concept, which we got out there last year, was a place that could bring in envirodata from all sectors and curate it and standardise it and make it more discoverable. So it's very much not an analytics platform, but attempt to build a trusted source where analytics users can plug in and pull that rich data for their own needs. So our platform is actually called Denju, which is Noongar for together. And we also built a platform that manages taxonomic names just to support Denju as well. So I'll be talking through those a little bit and about some of the data curation work we do and how that ties into protecting sensitive species. And I'll talk about them in the context of managing that information appropriately. So go on to the types of challenges that we faced in building a new platform. So we have a very conservative policy in WA at present around suppressing the precise locations of conservation listed species. So we don't really have any tiering like we've discussed in New South Wales at this point. And we've also been directed that we have to suppress species that are on the priority list here, but not under statutory listing as well. So that means we're looking at quite a lot of species where we have to control the data. And that's something that may change over time, but that's where the policy sits here now. So that means that there are a lot of taxa that we need to protect when we're building a public-facing interface for our product, which is the bit I'm going to focus on today. So we're still happy to make reduced precision data available to the public, and that's actually sufficient for many regulatory purposes as well as for public users. And we basically came across two classes of issue when we were trying to look at doing this in a responsible and accurate way. And one set of challenges were around the technical problem, where we were seeing problems where people could reverse engineer reduced precision data to get those more precise locations. But the other challenge was a curatorial one. So conservation codes change over time, but so do taxonomic names. So the name on data that comes in for a species might actually not be the name it's listed under today. So I'll take you through the technical one first. We've operated systems in this jurisdiction in the past, has many jurisdictions where users can go search an area and extract a list of unique species in that area. That's for us a really big ticket feature for industry and many of the regulatory processes here. But what we actually found was giving a couple of our data engineers a couple of hours with old systems that did that. And they went, oh, we found 4 or 5 different ways that we can instantly get the precise coordinates and narrow down or significantly narrow down where something they shouldn't be seeing actually is living. And they were quite varied, but we saw a lot of things around working around constrained zoom levels, which is something some agencies use to stop people zooming down too much, but also scripts that can bump your search area around by 1 pixel on the screen, and you can end up writing that and quite quickly pulling out all of the exact locations for something. So we thought those legacy approaches to providing that species list functionality with the threatened species in it weren't fit for purpose. And this was a really big challenge for us because we wanted to push that functionality out in our first release because it was such a big deal for our regulatory users. But we couldn't afford to release something where someone could blog the next day, hey, look, I found this new platform and I've extracted these species. I found a huge vulnerability as well. So we ended up going live with a beta with non-listed species visible to the public only, and went back to nailing down a new approach for WA. So the goal with that was to define a methodology we could use and that could be put out there and picked up by other agencies, and potentially not even the enviro sector, but there are other agencies in WA that have a similar shape problem as well. And some of the best guidance around this comes actually from GBIF. There's a paper if you go to the Global Biodiversity Information Facility website around this, and it provides some really good direction on developing a really robust, repeatable grid-based approach. So the way this works is that everything that was a dot in a specific place becomes a polygon that's a grid square. So when you search for it, if you cross that grid square with your search area, the species will come up in your species list. So it steers completely away from randomization for some of the reasons that are discussed. And in terms of the way we're applying it, it makes rounding somewhat unnecessary for us. So we're not kind of creating a sense of precision with a specific lat and long, but we're actually reducing it to saying, actually, this square is where the species is. It also has some really nice tweaks that we can't necessarily implement here because our data is from all over the place. It's not necessarily just departmental data. There's a lot of industry data and other stuff as well. But it does have, similar to the New South Wales categories we were looking at, you can change the size of your grid square to accommodate different risk appetite for different categories of species if you have that in your state. And you can also, it has some modifications you can make to accommodate radiuses of uncertainty if that comes consistently in the data that you have as well. So it definitely looked fit for purpose for our platform and what we were trying to do. But we did want to try it in real life before we put it out there in the wild. So we made a sandbox, which was a really simplified implementation of Danju with some synthetic data. And we ran a virtual hackathon and we put the challenge out to other departments and organisations to try and break our methodology. And we got a really diverse group of people who participated. They certainly weren't all experts in biodiversity data or in GIS, but some from both, some from human services departments, some researchers as well. So they came with very different prior knowledge. And it was a really good event and people were really creative. We were really happy no one could write a script and grab the lot, so it did stand up to that very well. But we did learn that there are some really interesting systemic vulnerabilities you can introduce depending on how much information you release beyond saying this appeared in this area in a unique species list. So if you start saying we have specific records that are here and you give people the records with a rounded coordinate or with that redacted in the lat long field, then if you're giving them information about who provided the data, so they can go, oh, it's part of this survey, and they can go, well, this survey also has records in here that are non-threatened, so I've got the precise locations. You can be very clever and sort of start almost following around the person who's obviously been on the ground making those recordings and draw some conclusions. So that really helped us go, this is very interesting, and it helps us make some decisions around what we can provide to users in the first instance that we know is really safe, and then think more about some of those things we discovered where people could use sort of analysis and look at the behaviour of collectors on the ground to try and break down the system. So that's led us to point where we are now, which is actually building it for implementation in Danju. And we've decided that In terms of risk, doing that unique species list feature with this grid-based methodology, we're really happy with, really comfortable. And then that's given us some time for future iterations to go, do we want to think about visualizing these on the map? Not particularly keen on visualizing them as reduced precision dot points, although can consider that just because it does sometimes for some users create a sense of false precision and lead people to go trampling around looking for things that aren't there in the first place. So that's something that we have to think through as well, and whether we'd prefer to show it with a heat map or show grid squares or something. But it means we can go straight out to industry in our next release with the really high value thing for them, which is that species list, which has every species in an area, cons listed or not. However, the other challenge, it was a really interesting one, which is not at all technical, it's very much curatorial. So this is because, as I said, cons listings and taxon names change over time. We have decades worth of data coming in, going back a really long way. So things coming in that have been recorded as one species may well have a new name now. Taxa split and merge, the conservation code won't be the same as the conservation code it may have had in an old data set. But we've got a mandate to restrict the public viewing what's conservation coded right now. So we had to overcome the challenge of going, well, the data sets we come in only have the old name for an observation. What do we do with that? And how do we keep this dynamic? This actually meant to do it, we needed a source of truth for taxa names and their full histories of anything that was popping up in our curation queue to hit our database, and also attach up-to-date conservation codes as well. So I ended up, to do this, literally building another system, which is called Nomos, that the museum named, and we worked with WA Museum and the Herbarium to populate it. So those organisations were our go-to sources, our sources of truth for native and naturalised flora names at the Herbarium, obviously, and fauna names at the museum. With plants, it's actually really good. The Herbarium has already a pretty robust database of both taxa names and histories for native and naturalised flora. So we can ingest that directly, and we've been working on some scripting to keep it up to date. Museum, like most museums, is a bigger challenge. So WA Museum only has checklists for some curatorial areas. And in other cases, they would direct us to their preferred source or database. So we had to work out how to ingest that and keep it up to date too. And another thing that made it difficult, for those of you thinking this sounds a bit like the National Species List, is that the differences between jurisdictions may be a relatively small number of species overall. But because we're building this with a really big focus for regulatory users as well, and state regulatory functions rely on WA names. So kind of going it alone here in WA, doing something a bit like the National Species List to support that. We also have the challenge of databasing names that aren't actually managed actively by the museum or herbarium at all. So we do see things come in for ingestion that may be ornamentals, invasive species and weeds, diatoms, getting better with databasing the fungi here, but there's a whole lot of stuff that it's no one's job to manage, where we're kind of taking that on then and working out how to get it into Nomos so we can accept data points that relate to those species. Because if a record can't, the name won't validate, then we can't curate and ingest it. So basically the way it works is that any record that comes in, it has a name that goes in the field that is the valid name when it was recorded. And we validate that to make sure it's not junk, it's a name. So anything that has a typo or something pops up for curation and investigation. But it also gets a new field, which is the most recent current name field. And that gets appended when records are ingested for the first time and pings the data from Nomos and goes, great, the name is either the same or this is the new name. But because things move, we actually have to keep that curation routine running across the whole database, which is currently up to 1.8 million records, but is growing every day. And so that means that every time the list of sensitive species changes or taxonomic names change, that curation script can run across the whole database and flag up anything that needs to be protected now that maybe didn't need to be protected yesterday. So anyone who's familiar with taxonomy at all will probably be thinking of some of the wild edge cases here. So there are subpopulations that are listed. Taxonomic splits are pretty tricky to handle. So we do have some business processes for flagging those that are in a bit more detail than I will go into here, but they're also something we have to tackle with our business processes. So just to finish up, I think the takeaway that we've found from actually trying to do this hands-on with the new system is that you have to accept that you can't fix everything. So a terrestrial species record on a tiny island, certain species that only occur in riparian areas, and you've got a road reserve data set from an agency that manages road reserves that only one river crosses. Like, these things happen, and somebody can probably draw a conclusion about one species occurrence from those, or even cross-referencing materials and papers with stuff that you find in a database like ours. But what we really wanted to do was to prevent people from systematically harvesting a whole lot of higher precision locations that they shouldn't have access to. And there's also that inherent trade-off, which I think some of the other presenters touched on too, which is making the data more available for decision makers across all sectors actually protect species as well, because they make better decisions. So suppressing data can actually lead to worse outcomes than sharing it. Our conclusion was, if you set your bar at no record can ever have its location narrowed down under any circumstance, you couldn't share any sensitive records at all. So in conclusion, I think the most important lesson for us is that this isn't work that you can do in isolation. You need to understand your data, and you need to understand all of the other things that sit around it as well, such as taxonomy. So we found that we have better outcomes in protecting this data if we work together, whether that's drawing on other jurisdictions for their best practice guidance and research they've already done, reaching out with a hackathon and having a diverse stakeholder group who can do some hands-on testing, and certainly working with the teams at the museum and herbarium and the team in our agency that deals with sensitive species, so that we can get that taxonomic names management right and make sure that records are still protected over time. So those people have been absolutely critical in making sure that we understand the risks and we make informed decisions and know what the consequence will be as well for users. So I'm happy to hand back to the ALA team now for questions.
Thanks so much, Ellen. And look, fascinating talk there, as they all were. I've got to say, look, coming at this from the ALA, it's actually really encouraging to hear that other people have some of the same problems we do. So thank you. Psychologically, that's been enormously helpful to me. Look, we've had a bunch of questions come through, and we're not going to be able to cover all of them right now, but I'm going to suggest a few. And I guess one thing that I want to pick up is that in a few cases, you mentioned sensitive species that weren't legislative, like Carlo, you mentioned yabbies, for example, and we talked about information on private land, which is a different kind of sensitivity from threatened. How are those decisions made? Do your organisation make them internally, or are there legislative requirements around private land? Like, how do you guys decide what gets determined to be sensitive? Sorry, anyone can take that. I don't mind who.
I mean, I can answer it for New South Wales. So there's a process where it's generally reviewed by the accountable officers for particular threatened species, whether they believe that something should be listed as sensitive. And then there's a checklist that they have to go through. But it's basically about looking at that balancing the risk of disclosure versus the risk of non-disclosure. And this will vary by jurisdiction, but in New South Wales, because the planning process has potentially so many levels and so many players, the risk of withholding data and denatured data or obfuscated data being treated as accurate data and so on, it can be quite high. And so if we want to make sure, as far as possible, the goal of the New South Wales government has been to be as open in data sharing as we can be, recognising risks. And there's also been a move into valuing biodiversity. So there's the biodiversity credits program, for example. There's some new moves being planned around natural capital. And so that's another advantage, is if biodiversity is valuable in the field to landholders, then the risk of the information becomes less. It's basically like for any species, it's a dynamic balance between the risks of nefarious uses versus the risk of neglect.
Thanks, Philip. Helen.
I didn't want to speak too much on behalf of our species and communities team, which is the team here that manages listings, which I'm not part of. But one thing that they do, as well as I mentioned, they have the priority listings as well as the statutory listings. And the reason they put something on a priority list are around not having enough data to know more about it. So there's different kind of buckets there. But the reason you put it on sometimes is to protect it, because there's a paper coming out that does indicate there may be a risk, and it takes a long time to get something listed through Parliament as well. But sometimes something comes up and nobody knows anything about this. It might be a risk, but if they put it on a priority list, it means that when proponents are going out there to do pre-work and surveying, when they want to do mine-site or whatever, that they have to collect data on that species if it crops up. So it means suddenly that data's flowing through to the department as well.
Yeah, it's a complex space, isn't it? Gola, you had something to add.
Yeah, I guess for BirdLife, it comes from our expert advice, and we do every 10 years. We've got the action plan for Australian birds as well, which identifies certain risks, and based on those, as you've seen in our rationale, some of the threatened species listing comes in. But being a community-driven sort of survey effort, there's also potential for perverse outcomes. So if you've got a exact location for a rare species that everyone wants to see, they all go to that spot, and we already know it's there. Versus if you obfuscate it a little bit, there's your charter for it, and we get information from a wider range rather than just from that one bird in one place. So there's a on the one hand, you want to avoid that that owl gets playback 365 days a year. And on the other hand, you really want people to find out where all the other owls are in the area. So there's a bit of that consideration as well.
No, that makes sense. Actually, I do remember from when I was a PhD student, two teams looking for the same pond with the same threatened frog in it, and one team doing call playback and the other one having automated recorders, and one thinking they detected it when it was in fact the other team there the whole time. So there are some slightly odd outcomes that I've heard of in that case as well. We've had a couple of questions about change over time, and I guess, look, a pessimistic view would be that things tend to become more threatened, but I suppose it is possible for things to become less threatened over time, and presumably these things are evaluated and then deobfuscated. Is that something that you've seen happen? Helen, you're nodding. That's positive.
Yeah, there are a couple of taxa, I think, in WA that have actually either sometimes you see them drop off entirely, which is wonderful if it does, but pretty rare. Sometimes you also see the category go down if recovery efforts are going quite well. So you're sort of hoping it will continue to drop down until it drops off the list and doesn't need to be obfuscated anymore.
Yeah, we've I guess there is a risk with things becoming more threatened in that old versions of your data will still be unobfuscated as well, right? This is something that we've seen happen at ALA, for example. There's potentially a contrast between the need to keep persistent data for things like DOIs against.
Yeah, that's why we ended up building the mechanism we have with the sort of dynamic curation, so that stuff is always suppressed in line with what the most current list is. So it does appear or disappear depending on changes to the taxonomy or changes to the WA list. It is really tricky.
Yeah, I guess what's encouraging though is that all three organisations, all speakers that have been here today, have mentioned severe challenges, but also the accepted benefits of sharing this data, and I think that's actually really encouraging. It seems like, and particularly I guess for BirdLife, who wouldn't necessarily have to share anything at all, being a community organisation, it seems you still see benefits despite those technical challenges. Is that a fair summary?
Yeah, definitely. And I think, as I said, like, I feel a great sense of responsibility. I think as an organisation, we ask our volunteers to collect this data, and I think it's really important that we're sharing it as widely as we can, just within keeping in mind that sensitive species need protecting. So yeah, I'm personally very much in the camp of let's get that data out there and into the right hands and used for conservation.
I mean, it's also important to point out, I mean, it's unfortunate, it's a historical thing that our policy was called sensitive species policy. And when we had the national discussion, there was a lot of discussion about what we should call it. And we hit on restricted access species, because the problem with calling it sensitive species is there's a tendency to conflate it with being threatened. And not all threatened species are necessarily at risk of exploitation. For example, I do surveys of a number of endemic plants here in the Blue Mountains, and they're on the cliffs. And so giving people exact locations of where they are, they're still very, very difficult to access. And if you wanted to grow one of them, you'd be better off going to the nursery than, you know, scaling down the cliff and trying to get access to these plants. Whereas the risks to those plants are things like recreational use, rock climbing, and so on. And where it's actually an advantage of us to have that information as widely available as possible, so that people in, you know, general public, people pining, rock climbing routes and so on, they have no excuse for saying that they didn't know that the threatened species was there. And so just because a species is threatened, those are highly threatened by, you know, recreational use, as I said, Phytophthora, inappropriate fire regimes and so on, but they're not necessarily threatened by releasing the data on where they are.
It's a really interesting distinction. I think people with less experience, such as myself, might not necessarily have thought of. Yeah. I wonder, we've had a question about biosecurity. Do you does obfuscation apply for biosecurity related species at all, or threatening species, if you will? Or is that a different issue entirely?
From the discussions I've seen, obfuscation isn't generally appropriate for biosecurity, because a lot of the main impacts of biosecurity are actually just knowing that a species is in Australia. So, for example, in a former life, I worked on a fruit fly eradication program in Queensland, and pretty much as soon as it was announced that papaya fruit fly was in Queensland, imports stopped immediately. So the risk is just about the course level information, and there's a lot of sensitivities about you know, reporting information, like an error, for example, in a database could end up having international ramifications. So it's generally not looking at sort of the location related information we're talking about.
Helen, you wanted to comment?
Yeah, I found the same. I mean, it did come up when we were in discussions around the RASO framework as well, certainly. But I think also some of the impacts depend on the type of database and the way you're putting the data out there. With stuff like the data we're getting, there is that lag between, like, it's coming from regulatory proponents and stuff. So it might be 12 months till it comes up. So it's not going to be, if it was a biosecurity issue that would cause a media incident or something because someone saw it somewhere, this isn't real-time data either. So it probably wouldn't be as big an impact for what we're doing compared to something that might be live tracking, where people might be nosing around and trying to make a story out of it as well.
No worries. Good to know. So we're nearly at time, and we get kicked off on the hour by the system. So rather than have that happen, I might call time now. And thank you so much for speaking today. It's been really wonderful to hear your perspectives. And yeah, tune in for the next one in 3 months' time. Thanks so much, everyone.
Thank you for the opportunity.